Now we're going to be getting into the world of inequalities. I've skipped over the sections on compound inequalities because absolute value inequalities are compound inequalities. So I'm going to kind of do two birds with one stone here. If you have any questions about prior sections, please feel free to contact me. The first thing we're going to do is an absolute value, and this is considered an AND inequality. Now how do you know that? Well, what I tell my students in class is that if you have a less than symbol, you can write out less than, and if you add a D to the N, you'll see that it's an AND. So you say it like less than. I know it sounds kind of corny, but it will help you to remember it. So anytime you see a less than symbol when you're doing absolute value, it's considered an AND inequality. Now what does that mean? Well, that tells you how to set it up. With an AND inequality, what's in the absolute value goes in the center. You copy the less than symbol on both sides. You want to make sure it's going in the same direction. And then you put this number, or the positive number, over here, and you put the negative number over here. Now if this was already negative, this problem would have no solution, because absolute value can never be less than a negative number. So if this is ever a negative, then your answer is no solution. The positive number always goes over here. So you bring this number down, and you put the opposite of this number on the left-hand side. This is what an AND inequality would look like, and you should have learned that from the previous section. Now in order to solve this, the first thing we're going to do is get everything away from the X in the middle, and make sure whatever you do to the middle, you also do to the right, and you also do to the left. So you've got three parts you're working with. The first thing we're going to do is get rid of that 4. So I'm going to multiply everything, or all three parts, by 4. Multiplying that middle part by 4 is just going to eliminate that denominator. They're just going to cancel out. So I'm going to end up with negative 24 is less than 3x minus 3. These 4's here are going to cancel, which is less than 24. Okay, that's my first step. Get rid of the 4 in the bottom. My next step is I'm going to get rid of that 3, the 3 that's subtracted, not the 3 that's multiplied. So in order to get rid of this, I got to do opposite. So I need to add 3. And you got to make sure you add it to all three parts. So I'm going to get negative 21 is less than 3x, which is less than 27. Now I've got one more 3 to get rid of, which is the 3 that's being multiplied. Opposite of multiplication is division. So I'm going to divide by 3, divide by 3, and divide by 3. So I'm going to end up with negative 7 is less than x, which is less than 9. That is my solution. Now, we have the two different types of notations we're going to talk about again. Interval notation, this is telling you x is stuck between these two numbers. Neither one of these numbers are included because there's no equal sign with the inequalities. So I'm going to start at the smallest, which is negative 7, with a parenthesis, and then I'm going to stop at 9 with a parenthesis. So again, it looks kind of like an ordered pair. This would be your solution in interval notation. Okay, in set notation, you would use the little braces. Okay, then you put x in the bar, which means x such that, and then you copy your answer. Negative 7 is less than x, which is less than 9, and then you close your braces. Okay, that's the difference between interval notation and set notation for this type of problem. Okay, now we're going to do a different type. And this was a AND absolute value inequality. And again, the reason why you know that is because of the less than symbol. Now let's look at the other type of absolute value inequality. This will be the other type that you will see, and this is called an OR absolute value inequality. Again, how do I know that? Well, if you look at the inequality symbol, this one is a greater than, and I tell my students in class, instead of spelling greater with an ER, spell it with an OR. So this is greater than. And then you can see that it's an OR inequality. And these are just little helpful hints to help you remember which one is which. Now an OR inequality gets set up entirely different than the AND that we just did. It works a lot like absolute value equations. You're going to have two separate inequalities. The first one, you're going to copy everything just like you see it, but you're going to drop the absolute values. So I'm going to do 3 minus 3x over 4 is greater than 9. Okay, then I'm going to add the word OR in the middle, and that separates my two inequalities. To do the next one, again, you copy what's in the absolute value, just drop the absolute value, but then you've got two more steps to do. You must flip the inequality symbol and change the sign of this number. Now again, here's the thing. If this number had been negative in the beginning or in our original problem, the answer to this problem would be all real numbers, because every absolute value number is going to be greater than a negative number. So these numbers have to be positive when you're doing these types of inequalities, whether it's a greater than or a less than like we just did. So this is how you set up an OR inequality. Copy it again, flip the inequality symbol, change the sign. And we're just going to solve these like they were two separate inequalities, but luckily they have the same steps. The first thing we would do is move this 3 over here, and I'm going to subtract it. And I'm going to go ahead and do both inequalities at the same time, since they do have the same steps. Alright, that's going to eliminate these 3's, and I'm left with negative 3x over 4 is greater than 6. And over here I have negative 3x over 4 is less than negative 12. Okay, next thing I'm going to do, now you could do the next thing that I'm going to do in one step, and I'm going to do it in 2 steps for you guys to see. The first thing I'm going to do is get rid of the denominators, which are 4's. So I'm going to multiply both sides by 4. Again, that's going to eliminate my 4's, and I get negative 3x is greater than 24. And then over here I'm going to get negative 3x is less than negative 48. Okay, then I'm going to do my last step, which is divide by negative 3. Now you have to remember from the previous lesson that when you divide or multiply by a negative number, when you're doing inequalities, it changes the order of the inequality symbol. So what's going to happen here is I'm going to end up with x is less than negative 8 because I'm dividing by negative 3. And over here I'm going to end up with x is greater than positive 16. Again, I have to flip the inequalities anytime you multiply or divide by a negative number. Now, when I was saying you could have done it in one step, up here at this step, if you wanted to get rid of the 3/4 at the same time, you could multiply both sides by negative 4 over 3. And that would keep you from having 2 steps, and you would just have 1. But a lot of people will mess that up, so I tend to tell them to do it in 2 steps. So here's my solution. Interval notation. Well, I'm going to start with my smaller number, which is the negative 8, going to the left. So I'm going to go negative infinity to negative 8, and use the little U symbol for the OR. And then I'm going to go 16 to positive infinity. Both of these, again, do not have the equal sign, so they're going to be parentheses. And by the way, the infinities are always parentheses. So even if these had the equal sign, the only brackets you would see is at the 8 and at the 16. Infinities are never included. Alright, set notation. Brace x in the bar, then you copy your answer. X less than negative 8 or x greater than 16. So again, the difference between interval notation and set notation. I hope this helps to clarify solving different types of absolute value inequalities.